Question 5. The probability of obtaining heads on a biased coin is 0.4. The coin is tossed 600 times. Write down the mean number of heads. So the first thing we need to do is we need to recognize that this is a binomial distribution. Actually, you could easily just do 0.4 times 600 because you know, but it's better if you recognize a binomial distribution somehow. You could even write down, if you wanted to, x is distributed binomially NP, so 600 and 0.4. That is how you would say it's a binomial distribution. And then the mean is the expected value of x, which, if you turn to your formula sheet, which is your best friend in these examinations, it should tell you that the mean of a binomial distribution is equal to NP, which is 600, times 0.4, which is 240. Part 2. Find the standard deviation of the number of heads. If you were working with an old formula sheet yesterday, then you will not have seen the variance formula, which is in the new formula sheet. So it's vitally important that in your real exam you use the correct formula sheet. So the variance of x, the variance of a binomial distribution, is equal to n np 1 minus p. Now we already know that NP is 240, so that's 240 times 1 minus 0.4 is 0.6, and that is, using your calculator, 144. Now that's the variance of x, which means the standard deviation is equal to the square root of 144, which is equal to 12. Now I know that many of you couldn't do that question, so then you got to part B, and it said find the probability that the number of heads obtained is less than one standard deviation away from the mean. And if you didn't get an answer for this standard deviation here, you couldn't do the second part. So what should you do if you're in that situation? Make something up, have a guess. Just write down here sigma equals 10 or something, and then use your answer of 10 in the second part. The examiner will give you follow-through marks if that is the case. If you just leave it blank, you will get nothing. So it really is worth just having a guess, putting something down, and then using the answer for part B. Obviously it's better to get the correct answer, but if we have a different answer, that's fine. So we need to make sure that that we do this. Always remember RTQC, read the question carefully, or indeed RTFQC, read the full question carefully. Find the probability that the number of heads obtained is less than one standard deviation away from the mean. So the mean take away one standard deviation, 240 take away 12 is 228, and 240 plus 12 is 252. So we want to find the probability that x is between, so 228 is less than x, which is less than 252. Now notice these are strictly less than, is less than one standard deviation away from the mean, not less than or equal to. Now when we use the binomial distribution, we always need less than or equal to. So that is the probability here that x is greater than or equal to 229 and less than or equal to 251. Okay, and then for this we would use the binomial distribution. We'll use our graphical calculator, our second best friend. So again it's statistics, again it's a distribution. This one is further down and binomial, and it is a cumulative distribution that we want. So number of trials is 600, an awful lot of trials. Probability of success, we've already seen, is 0.4. The lower bound, now remember this is less than or equal to, so that is 229. And the upper bound is 251. Type that in, we get 0.662109. So 0.662 104, and we should round that to 0.662. And remember what I said to you before, you should really, to show you're working, you should really write this down. So let's do bin CDF 600 0.4 299 251, and they do now accept these calculator notations as part of your working as evidence that you are using the correct method.